Hi everyone, the first unit of our book is titled Symmetry. It's the first unit of chapter 1, and if you look at this diagram here, this is a New York Times crossword puzzle, and it has a specific type of symmetry, and as we introduce the concept of symmetry, please see if you can figure out what type of symmetry that the crossword puzzle has. Okay, so let's, very first thing we want to do here is kind of define what symmetry is. So symmetry is when you have parts that are identical after a flip, a turn, or a slide. Okay, and there's different types of symmetry. The first three things here represent the first type of symmetry, which is reflectional symmetry. And basically it's talking about the type of line that the figure would be reflecting over. So if I look at this thing over here to the right, it's a stop sign without the word stop in it. It has horizontal symmetry because if you flip the top over to the bottom over a horizontal line, it is identical. Same thing with vertical. It has vertical symmetry also, because if I draw in a vertical line and you reflect the left side over to the right side, it is identical. It also has an oblique line of symmetry, and the line of symmetry looks something like this. So it's not horizontal, it's not vertical, it is oblique. The next type is what we call rotational symmetry, and that is when you rotate the figure and it has to the point where it looks identical to the original. And so if it rotates, a specific type of rotational symmetry is point symmetry. That is when you rotate a figure 180 degrees and it looks identical. So if I take this center point here and I rotate this point all the way around 180 degrees all the way to here, so I rotate this entire figure 180 degrees like this, it is going to have rotational symmetry. And in particular, it's going to have point symmetry because it's 180 degrees. A stop sign has rotational symmetry, not just point symmetry. It has rotational symmetry, and it has many different degrees of rotational symmetry, but what you generally do is you would refer to the smallest degree of rotational symmetry. So if I think about this as, going around the circle is 360 degrees, you have to think about, okay, if I rotated from this point and spun and rotated it around the circle and rotated this point over to here, how many degrees of rotation would that be? And so there's basically, it's an octagon, so there's 8 of these points. And so you would do 360 degrees divided by 8, and it would be 45 degrees. So that is going to be 45 degrees of rotational symmetry. The last type of symmetry is translational symmetry, and that's basically when you move it by some direction and some distance. And later on we'll talk about this as we introduce the concept of vector. Some of you will see this in your physics classes. Okay, so let's try some problems here dealing with different types of symmetry. Oh, so let's actually look back at the crossword puzzle. Okay, have you identified yet what type of symmetry this has? Well, this crossword puzzle, as well as all New York Times crossword puzzles, have rotational symmetry. So if I pick a point like right here, all these points are going to be rotated 180 degrees. So for example, this point right here, it rotates 180 degrees over to here. If I pick another point, let's say I pick this point right here, it's going to rotate 180 degrees over to this point right there. So everything in this figure is basically has point symmetry. Okay, so one way to think about it, by the way, is if you just take the figure, and if I take your piece of paper and I flip it upside down, it's going to look identical. This figure right here is going to look identical if I flip it upside down. All right, let's try this problem down at the bottom here. It talks about filling in a correct square to make this a real crossword. So in other words, it's going to have rotational symmetry. And if you think about it, it just means that if I flip it upside down, it's going to have the exact look as these right here. So this particular square right here is just going to end up right over here. And likewise, this square right here is going to end up over here. And I can keep on doing all these same things. This one here will just end up right over here. Okay, and if I fill in all the squares, it's going to look something like this. So that whether I flip it, if I just flip this over, upside down, the piece of paper upside down, I'm going to see that the orange pieces are exactly where the blue pieces were in this figure. All right, let's flip over to the back side now. Okay, so we're going to take a look at a couple more of these figures here, and what I want to do on the first figure is if I draw in an oblique line going across like this, what I want to do is I want to be able to reflect, give this thing reflectional symmetry, and reflect the blue squares and create a bunch of resulting squares. So for example, this one right here will reflect over that red line and have a box right there. And then I can do the same with like this one. It's going to go straight across. If you notice, it's going to go the same distance from here to here as it does from here to here, and it's going to form a right angle. So it's going to be perpendicular. And so that one's going to end up right there. And I can keep on filling all these in. You're going to end up with this one right here. Let's try a different color here. Yellow one's going to end up, probably not a good idea to use the yellow, but it's going to end up right over here. Hopefully y'all can see that. And if I just go ahead and fill everything else in, you're going to end up with one here, another one here, and I think that's it. Okay, so you ended up with 1, 2, oh yeah, that one's already flipped over. Okay, Now if I go the other direction, let's say I draw a line in this way, and I want to give it flexural symmetry, do the exact same thing, right? This one is going to end up right over here. This one's going to go across this way and end up right there. And if I go ahead and fill out the rest of them, you're going to end up with something that looks like this. Okay. Let's skip the rest of this. Just want to point out one thing down at the bottom here. There's a bunch of these on, if you take your iPad and just type that into the search when you're looking for different iPad apps. Try downloading one of them and see if you can play with the symmetry tester, and basically you can find out if your face is symmetrical. See if when you plug it into that app, your face actually looks normal. Okay, that's it for now. All right, take care.